Installation and Operation Manual for Horizontal Split Case Pump. This manual covers the installation and operation of Syntec make horizontal split case centrifugal pumps. When properly installed and when given reasonable care and maintenance, centrifugal pumps should operate satisfactorily for a long period of time. The axially split casing design allows removal of the impeller and bearing housing assembly without disturbing suction and discharge piping. Storage and protection. All pumps are shop tested and ready for operation when delivered. If equipment is to be stored for long periods of time, 6 months or more, should be kept in a clean, dry area, and the following precautions should be taken to ensure that the equipment remains in good condition. Be sure that the bearings are fully lubricated. The shaft should be rotated 10 to 15 revolutions by hand periodically in order to spread the lubricant over all the bearing surfaces. Suitable intervals are from 1 to 3 months. Installation. The pump should be located as close as possible to the liquid supply so that the suction line is short and direct. Location should require a minimum of elbows and fittings in the discharge line. Before installing the pump, ensure that the foundation on which the pump will be placed is prepared well. It has to be sufficiently substantial enough to take the weight of the pump and absorb any possible vibrations from it. The foundation has to be absolutely straight, without any inclination or tilting on any side. The foundation bolt of proper size should be embedded in the concrete and base plate tightened, ensuring that it is level in all directions. Piping associated with the pump must be anchored and supported independently of the pump and should never put any strain on the pump casing. When the pipes are not supported, their weight is borne by the pump casing and may cause them to crack or deflect. It is important that the connections be carefully aligned axially, angularly, and in length. Suction piping in case of static suction lift condition, negative suction. The piping run and the connection fittings should be properly aligned and supported separately. The elbow should be of long radius type. All suction piping must be airtight. The suction pipe should be sized to ensure the liquid velocity of not more than 2 meters per second. All suction pipes should have a continuous rise to the pump suction inlet. 6 mm per 100 mm slope is recommended. The recommended suction pipe size should be at least one commercial size larger than opening of the pump inlet. No isolation valve is recommended. There should be a tapping provided for installing a vacuum gauge in suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer, with the inclined side of the reducer as the bottom side. The straight length of the pipe after the eccentric reducer should be 2 times of the pipe diameter. The suction strainer must be at least 4 times the suction pipe area, and the mesh sides should screen out solid particles that could clog the impeller. The minimum depth of submergence of the strainer should be at least 4 times the pipe diameter measured from upper row of holes of strainer. The distance between the bottom of strainer and the floor of the tank should be considered as 2 times of pipe diameters. A stream of liquid falling into the pump near the intake pipe will turn air into the liquid. The supply line should extend down into the liquid. A short elbow should never to bolt directly to the pump's suction nozzle. The disturbance in the flow caused by the sharp bend so near the pump inlet may result in noisy operation, loss in efficiency and capacity, and heavy end thrust. If separate suction lines cannot be used for each pump, then a tapering header with Y branches should be used. A straight branch header should never be used. Suction piping in case of flooded suction condition. Positive suction. In case the water is being supplied to the suction through gravity, example, an overhead tank, a slightly different setup is needed. The elbow should be of standard type or of the long radius type. Isolation valve should be provided in suction line. The pipe supplying from the tank into the pump should have a descending inclination. The straight run of the piping leading to the pump suction nozzle should be at least 3 times to 6 times the diameter of the pipe from the upstream elbow. The suction pipe should be sized to ensure a liquid velocity of not more than 3 meters per second. There should be a tapping provided for installing a pressure gauge in suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer with the inclined side of the reducer as the top side. Stuffing box seal connections are usually made from the top of the pump casing. If the liquid being pumped is unsuitable for sealing, then it is preferable to bring fresh, cool water to seal connections from an outside source. Centrifugal separators or other filters may be used to remove abrasive particles from the liquid being pumped if an outside source is not available. Description of the discharge pipe. The piping run and the connection fittings should be properly aligned and supported separately, reduce strain on the pump casing. There should be a pressure tapping as close to the pump outlet and before the isolation valve as possible to measure the pump shutoff head. Concentric reducers are installed in the discharge pipe to minimize friction losses. The check valve used in the discharge should be of non-slam type to prevent reverse flow and protects the pump from excessive back pressure. The isolation valve is provided downstream of the check valve so that these can be taken up for maintenance, priming and starting whenever required. The recommended discharge pipe size should be at least one commercial size larger than the opening of the pump outlet. The number of fittings and size changes should be minimum to prevent fluid friction losses. Expansion joints may be used only after a careful piping analysis, especially when the discharge pressures are on the higher side. Installation of pump and prime mover. The pump and motor unit needs to be fitted firmly onto the base frame using nuts and bolts before fitting in any pipes. It is essential to confirm the distance between the shaft ends. In the subsequent step, the pump and motor are aligned to the final tolerance using a reverse dial gauge or a laser alignment tool. After the alignment is completed, the piping associated with pump should be bolted. Once this is completed, the alignment should be rechecked and similar readings should be obtained. If this is not the case, then the piping should be investigated and suitable corrections should be made. If this is left unattended, it can cause stress on the pump casing. Misalignment may be the cause of noisy pump operation, vibration, premature bearing failure, or excessive coupling wear. Once the pump and motor have been coupled, test the movement manually by rotating it by hand to see if it is rotating smoothly. Operation. Before bolting the coupling halves together, Check the drive rotation to see that it matches the pump rotation. Starting. When possible, turn the pump shaft by hand to ensure that the parts do not bind. Check the bearing lubricant. Open the valve in the pump suction line if fitted. Close discharge valve. Prime the pump. Open valves in stuffing box seal lines if fitted. Start driver. Open discharge valve slowly when the pump is up to speed. Adjust the packing gland until there is a slight leakage from the stuffing box. Mechanical seals need no adjustment. There should be no leakage. Shut down. The pump may be stopped with the discharge valve open without causing damage. However, in order to prevent water hammer effects, the discharge valve should be closed first. Close discharge valve. Stop driver. Close water seal valves. Close valve in the pump suction line if fitted. If danger of freezing exists, drain the pump completely. For further information, you can email your queries to us on service@syntechpumps.com.